Do you ever wonder what's really holding together all the apps you use every single day? From your social media feed to your banking app, there's this invisible, totally essential structure working behind the scenes. Well, today, we're going to pull back the curtain on that very structure. And it all starts with a pretty simple question.
Now, seriously, think about it for a second. Can you imagine trying to build a massive skyscraper with no plan, no guide for where the walls go, how the plumbing connects, or where all the wiring is supposed to run? It would be absolute chaos, right? It'd be unstable, unreliable, and pretty much doomed to fail from the start.
And that right there is the big idea for today. And applications data needs a solid plan, just as much as that skyscraper does. Because without one, you're basically just piling up information with no order, no structure, and that is a recipe for disaster.
So, when we talk about a blueprint in the world of data, what are we really talking about? Well, it's the master plan. It's the fundamental guide for how all of an application's information is going to be stored, organized, and managed.
A database schema is exactly that. It's the blueprint. And here's the key thing to get. It's not the data itself. It's the architectural plan that tells everything where it's supposed to go. It defines the tables, the relationships between them, and all the rules the data has to follow to keep things in order.
And this is such a great way to clear up a super common point of confusion. See, the database is the actual data. It's the furniture, the people, all the stuff inside our skyscraper. It's always changing. But the schema, that's the blueprint. It's the fixed structure, the walls, the floors, the whole layout that rarely, if ever, changes once it's built.
Okay, so why should we care so much about having this blueprint? What's the real-world difference between a well-designed schema and, a messy one? Oh, the benefits are absolutely huge. For starters, a good schema makes sure your data is consistent and reliable. For instance, it stops someone from accidentally entering their birthday into a phone number field. It also makes your database way faster because the system knows exactly where to look for information. And maybe most importantly, it makes the whole application so much easier for developers to understand, maintain, and expand as it gets bigger. It's really the foundation of a healthy app.
All right, let's zoom in a little. Let's take a look at the individual parts of this blueprint. One of the core building blocks that every data architect uses to design a schema.
So first up, we've got tables. These are the most basic containers for our data. If the whole schema is our building's blueprint, then you can think of tables as the individual rooms. You've got a room for users, another for products, maybe one for orders, and so on.
Now, inside each of those rooms, or tables, we have columns. Columns describe the specific pieces of information we're storing. So for a user's table, the columns might be things like name, email, and age. They're like the features of the room. Its size, the color of the walls, where the windows are.
But wait, how do we tell one room apart from another? I mean, if we have a million users, how do we find just the right one? Well, that's where the primary key comes in. It's a totally unique ID for every single row of data. You can think of it like the room number on a hotel door. No two rooms can have the same number, which means every single record is guaranteed to be one of a kind.
So now we've got all these rooms. How do we connect them? That's the job of a foreign key. It's basically the glue that holds our tables together. If our tables are the rooms, then foreign keys are the hallways connecting them. They create these crucial relationships, letting data in one table refer to data in another. Okay, theory is great and all, but let's see how this actually works in the real world. We're going to quickly design a simple blueprint for a school database using all the components we just talked about. First thing we do is create our student table. This is our first room. You can see we've got columns for name and email, and most importantly, we have student ID, which is our primary key, the PK. That's the unique room number for each student. So John Doe is student number 1. Simple enough.
Next up, we need another room, this one for our courses. So we'll create a course table. It's got columns like course name and credit. Its primary key is course ID. So Intro to Physics is officially course number 101. Okay, so now we have two separate, totally unconnected rooms.
So now the big question is, how do we show that John Doe is taking Intro to Physics? We've got a student room and we've got a course room, but there's no way to link them together. We need a hallway.
And here it is. This is our hallway, the enrollment table. Now notice it doesn't store the student's name or the course name. It just stores IDs. It has its own primary key, enrollment ID, sure, but the real magic is in the foreign keys, the FKs. By putting student ID 1 and course ID 101 in the same row, this table creates a direct link. It officially enrolls John Doe in Intro to Physics. This is exactly how relationships are built.
So now that you get the basic components and how they all fit together, let's go over some quick but really essential rules for designing strong, effective blueprints. These are the principles every great data architect lives by.
First, always normalize your tables. That's just a fancy way of saying don't repeat the same information in multiple places. Second, please use clear, meaningful names. Student name is so much better than something generic like call 1. Third, and this is so important, define your keys properly. Every room needs its unique number, and the hallways have to connect to the right places. Fourth, use constraints to enforce rules, like making sure every email address is unique. And finally, always design with the future in mind. Keep it simple, but build it to grow. Look, if you take only one thing away from all this, let it be this. The schema isn't just some minor technical detail. It is, without a doubt, the single most important foundation for your entire application. A great schema means you get a fast, reliable, easy-to-maintain product. A bad one, well, that leads to endless headaches.
So, I'll leave you with a final thought here. Every single app on your phone, from your music player to your rideshare app, is built on a database schema. So the next time you open one up, just for a second, try to think like a data architect. What do you think the tables are?